Welcome back. Today we're going to be looking at systems of equations again, and today specifically we're going to be looking at the first method for solving systems of equations, and that's solving by graphing. Now as we get into the lesson, we're going to be looking at graphing by hand as well as graphing using the calculator. All right, let's take a look at our first example. So if you recall from the last topic, we were introduced to the system of equations. And so a system of equations is two or more equations where they have a common solution. And so on a graph, that would represent the intersection point, or where the two graphs intersect. Now, when we're solving by graphing, if we're going to be solving by hand, the first thing we need to do is get our equation written in the format y equals mx plus b, and that's because that's the easiest way to graph by hand. Now, sometimes certain linear equations that we work with are not so easy. The y-intercept might not be a nice number, and so we may have to use tables of values as well. Now, if you recall from our previous unit on linear functions, the m value stands for slope, so that's rise over run, and the b value represents the y-intercept. Now in this first example, our equations are already written in slope-intercept form, so I'm just going to label them with different colors so that as we graph them we know which is which. So equation number 1 is y equals negative 2x minus 3. So you start by plotting your y-intercept, which is negative 3, and your slope is negative 2. So if the slope is negative 2, that's the same as saying negative 2 over 1. So down 2, right 1, or up to left 1, and so on. Now from there we can graph our line, and we'll make sure that we extend that line through the entire graph, and it'll have arrows on either end. So using a straight edge is going to be important as you work through these graphing questions. Now if we want to graph the next one here, we'll start by plotting our y-intercept. Our y-intercept is positive 3, and our slope is 1. So up 1, right 1, up 1, right 1. Notice I'm not saying up 1 over 1 because over doesn't give a clear direction. So up 1, right 1, or down 1, left 1. All right, so we're going to draw a line again. And we'll recolor it so that it's different. And so there we have our two intersection points. Now, if I were to circle that intersection or draw a big dot around it, the intersection would be right here. So my solution would be at negative 2, comma 1. Now, whenever we're doing these questions, it's really important that we check our answers. The nice part about this unit is that there are multiple ways to check your answers because there's multiple methods for solving. But if we want to verify that a coordinate is a solution, then we make our left side, right side chart, and we need to do that for both equations. Because the only way to be a solution, or to guarantee that something is a solution, is if that coordinate works for both equations. So we start by making our t-charts. We label them left side, right side. So for the first equation here, our LSRS, we'll use blue. Left side of the equation is y, right side of the equation is negative 2x minus 3. Well, I'm going to plug in my x and my y values. So y is 1, x is negative 2, and negative 2 times negative 2 is 4, minus 3 is 1. So this one is a solution, but it has to work for both equations in order to be a solution to the system. And the only way to be a system of equations is if there's a solution that works for both. So left side is y, right side is x plus 3. Well, our y value is 1, and x is negative 2 plus 3, which is still 1. So this is a solution. So your solution to this system is negative 2, comma 1. All right, let's take a look at another example. So in the next example, we have 3x plus y equals 11 and x minus 2y equals 6. So again, we're going to start by, I'm going to color code. Equation 1 will be blue, equation 2 will be purple. And again, we have to start by rearranging our equations. So the first one here can be rewritten as y equals negative 3x plus 11. And the other equation, we have negative 2y equals negative x plus 6. I'm going to divide by negative 2. And that gives me y equals 1/2 x minus 3. So we'll start by plotting the first graph. We have a point at positive 11, so just off the grid. Down 3, 1, 2, 3, right 1. And so on. And once we have a few points, we can usually graph our graph. And so let's start there. Obviously, the more points, the more accurate your graph will be. Now for the second one, our y-intercept is at negative 3, so 1, 2, 3, and then up 1, right 2, up 1, right 2. You'll often find that as you're graphing these, you'll see the solution before you've actually plotted the full line. And that's okay, but we still want to see that you complete all steps. So we've got our equation, our line here, draw right through the entire graph, and then our solution. So our solution is right here at 1, 2, 3, 4, negative 1. So our solution is at 4, negative 1. Again, in order to verify that this is accurate, we need to create our left side, right side charts. So we're going to have a left side, right side for the first equation, and a left side, right side for the second equation. All right, so the first equation here, we've got 3x plus y equals 11. Notice that I'm always going to go back to my original equation, not my manipulated version. So 3x plus y equals 11, because that's the best one to check. That's the original question. We could have just as easily made a mistake in our first step just by rewriting things. So it's always good to verify with the original question as much as you can. So 3x plus y and 11. So 3 times 4 minus 1 is 12 minus 1 is 11. So the solution works for the first equation. Checking the second equation, our left side is x minus 2y. Our right side is 6. So we have 4 minus 2 times negative 1, which is 4 plus 2, which is 6. So this is our solution. 4, negative 1 is the solution. And one more example here. We have x plus 3y equals 4 and 2x minus y equals 8. Now this one's a little trickier because when we go to graph it, we're not going to have a clear y-intercept for one of our equations. And so I'll show you a couple workarounds that you can do. So first equation I'm going to do in purple. And we start by rewriting the equation. We have 3y equals negative x plus 4. We divide by 3 on all sides. Y equals negative 1/3 x plus 4/3. Well, this one isn't as nice to graph just by plotting our y-intercept because 4/3 isn't a nice round number that we can plot. Now, taking a look at equation number 2, we've got 2x minus y equals 8. So we're just going to swap the y and the 8, and we're going to have y equals 2x minus 8. Okay, now that one's a little easier to plot, so I'm going to plot that one first. Now we have negative 8. Negative 8 down here. Slope is 2. So 1, 2 over 1, 1, 2 over 1, and so on. And again, once you have a few points there, you can plot your line. All right, now for the purple graph, it's tough to try to find that 4/3. And so what we're going to do is we're going to make a table of values. I'm going to make, just grab color here. I'm going to make a table of values, and I'm going to pick numbers that are going to give me nice coordinates. Now, I really only have to find one coordinate, and then I can count my slope from there. But if I have negative 1/3 x plus 4/3, I can do a little bit of guess and check. I can also use my graphing calculator. So on my graphing calculator, I would go to y1, and I can type negative 1/3 x plus 4/3. Zoom standard, so zoom 6 will give me my standard points. That's what the graph's going to look like, but I want to just build my table of values. So I can go to second function table, and it will give me a table of values there. And I'm only going to write down ones that give me nice numbers. So 1 and 1, 4 and 0. So those ones will work. So 1 and 1, 1 and 1, 4 and 0. If I look at some other ones there, I have negative 2 and 2, and so on. So I plot those points 1 and 1, 1, 2, 3, 4 and 0, and negative 2 and positive 2. So from there I have enough information to graph my line. And once we have it graphed here, I'm just going to change the color. Once we have it graphed, again, we can recognize or identify our solution. So solution happens to be right here at 4, 0. And again, you can verify using your left side, right side chart. I'm also going to be getting into showing how you can verify with your calculator. So again, the next step would be to do a left side verification chart. I'll save that step here for now, but that would be what you would do if you're asked to verify. All right, so we're going to move on to the graphing calculator. All of the questions that we've done so far can be verified using our graphing calculator. And so I'm going to go through some steps here, and if you'd like, you can go back and check the other ones with your graphing calculator. Now, when we want to graph on our calculator needs to be in the form y equals mx plus b, or at the very least, it needs to be in the form y equals. So you don't necessarily have to have it fully simplified to mx plus b, but you do have to have the y isolated by itself. So for equation number 1, we have 4x plus 3y equals negative 15. In order to graph that on my calculator, I need to rearrange the equation. So I'm going to have 3y equals negative 4x minus 15. I'll divide by 3, and that gives me y equals negative 4/3 x minus 15 over 3. And then equation number 2 is y equals x plus 2. So that's just y equals x plus 2. So when you want to graph on your calculator, you'll start by going into your y equals. You'll make sure that everything is cleared. Equation number 1 is going to be negative 4/3 x minus 15. So negative 4 divided by 3x minus 15 over 3. Now it's really important that you make sure everything is entered correctly and that you're using the negative symbol, not the subtraction symbol. All right, for the second equation here, we have y equals x plus 2. If you're having any challenges with the calculator or you haven't had a chance to practice enough, you can always go back and look at the graphing calculator tutorial video that we did earlier in the semester, and it's under the course resources section in Google Classroom. Now, once we have these graphed, we can hit the graph button, but if you've been doing anything in your calculator and your window settings are off, you might want to choose zoom standard. So a zoom standard is a 10 by 10 window, so negative 10 to positive 10, negative 10 to positive 10. So if you were to click on your window settings, you'd notice that we go from negative 10 to 10 up by 1, negative 10 to 10 up by 1. If we were listing these out, so this is essentially your domain and range for that, just for the grid. So these are your window settings. You'll often see your window settings set like this: 10, negative 10, 10 up by 1. So that would be your x values, and then our y values would be negative 10 to 10 going up by 1. So if you see something written like this, those are just indicating your window settings. All right, so now we have these graphs graphed, or these functions graphed on our calculator. We can certainly graph by hand to verify that. So for example, this one here, if I wanted to verify, I'd have x plus 2, up 1, right 1, and so on. Okay, and I'll do a quick sketch here. I got that one there, and then the other graph, I was at negative 15 over 3, which is actually y equals negative 4/3 x minus 5, so that can be reduced. So 1, 2, 3, 4, 5, negative 5, and then we're going up 4, 1, 2, 3, 4, left 3. And 1, 2, 3, 4, left 3. So again, nothing changes. We can still graph these by hand just as easily. But if I'm graphing that up there, I must have counted wrong on that last one. So we're going 1, 2, 3, 4, 1, 2, 3. Yeah, that one's off the grid. And so our solution right here is 1, 2, 3, negative 3 down 1. So I would expect to see that solution on my calculator. So on the calculator, once you have these graphed, you're going to go second function trace or second calc, and you're going to choose 5 for intersect. Now, at this point, you're going to be asked first curve, second curve, and guess. Well, the first curve, they're just asking, is this one of the lines you want to intersect? You'll notice the equation is written up top. You'll hit enter. Second curve, is this the second equation? You'll notice the equation's changed up top. You'll hit enter. And then they say, do you want us to figure it out? And you say yes. And so we have negative 3, negative 1, which is what we had when we graphed by hand. So I'll go through that a little quicker. Second trace or second calc, 5 for intersect, and then enter, enter, enter. When it's two straight lines, this works perfectly fine. If we had a nonlinear function, we might have to move our cursor to get closer to one intersection versus another. So we've got negative 3, negative 1. Now, if I wanted to put that into my calculator in a different way, I could think just through the algebra. So I ultimately want y by itself. And so to get y by itself for equation 1, I'm going to go negative 15 minus 4x and then divide by 3. Well, I can put that in my calculator as long as I remember to use brackets. So negative 15 minus 4x, close your brackets, divided by 3. Now let's see what we get when we graph this. Looks pretty similar. Second calc 5, enter, enter, enter. Exact same solution. So I've typed it in slightly different, but I'm still getting the same answer. All right, let's take a look at another example here. So we've got 2x plus y equals 2 and x minus y equals 7. So the first equation here, we're going to have y equals negative 2x plus 2. And the second equation, we have y equals x minus 7. And so let's take a look at what that looks like on our calculators. So on our calculators, we're going to graph y equals negative 2x plus 2. Again, make sure you're using the negative and not the subtraction sign. And x minus 7. And this time I'm going to use the subtraction sign. So I've got those two graphed. I can go second calc 5. Now, again, you might want to graph it first. There'll be a little bit of a delay there, but enter, enter, enter. And I have a solution of 3 comma negative 4. So notice that we're going second calc 5 for intersect. Now let's just do a quick verification. We can use the left side, right side chart, or in this case, I'm going to graph it. So negative 2x plus 2. So we start at the positive 2, down to right 1. Graph our line. And then the other one is negative 7 with a slope of 1. So negative 7 is off the chart. So again, you might want to use a table of values here. Let's say, for example, I want to use x equals 4. Well, 4 minus 7 is negative 3. So 1, 2, 3, 4, 1, 2, 3 would be an answer. And from there, I can count my slope again. Up 1, right 1, or down 1, left 1. And so I can draw this line. And my intersection point happens right here at 3 comma negative 4. So that just verifies what I did on my calculator. All right, we're going to try a couple more examples. Sometimes we can't graph them as easily if we're dealing with decimals, and this is anytime we have these decimal type questions, we're likely going to be using a calculator. So if ever you're told to graph using technology, so if you're asked to graph using technology, that means use your graphing calculator. And that means they're not going to be nice numbers that you can graph easily. So this one here is already written in y equals mx plus b. We're going to graph the equation. We've got 3x minus 2, so 3x minus 2, and we have negative 0.5 or negative 0.5x plus 4. Whether you put that 0 there or not doesn't change the question. So we're going to graph them, and second calc intersect, enter, 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 and they intersect at 1.7 and 3.1. So solution would be 1.7 and 3.1. And again, you could do a quick sketch here. We've got negative 2, up 3, and again, draw your graph. And the other one is positive 4. So 1, 2, 3, 4. And negative 0.5 means down 1, right 2. Down 1, right 2, and so on. And so we'll draw that graph. And so you'll notice that there is an intersection point, but it's not right on a clear line, but 1.7 and 3.1. Let me see. Yep, so just a little bit above 3.1 and just a little bit below the 2 there. So again, when it's not nice numbers, we can't be accurate when we're graphing by hand. All right, so the last example here, we're going to do this one on our calculator. So we've got 2x plus y equals 7 and 3x minus 2y equals 6. So again, the hardest part about this is just manipulating your equation. So we're going to have y equals negative 2x plus 7. And this one here, we have negative 2y equals negative 3x plus 6. I'm going to divide by negative 2. And that gives me y equals 3 over 2x minus 3. So on our graphing calculator, we're going to graph negative 2x plus 7. And we're going to graph 3 over 2x minus 3. And we'll graph. And then second calc, 5 for intersect, enter, enter, enter. And we have a solution at 2.9 and 1.3. Now, one last thing I want to show you again, when we're entering these into our calculator, we can just think algebra as well. So when you're putting in your calculator, as long as what you're putting in is accurate, the format isn't necessarily as important. So for the first one here, I've got 2x plus y equals 7. Well, to get y by itself, I'm going to subtract 2x from both sides. So I could also just have written 7 minus 2x. And then for the other equation, I would have first subtracted 3x, so in brackets, 6 minus 3x. And then to get the y by itself, I would have had to divide by negative 2. So this would simplify down to 3 over 2x minus 3, but in my calculator, I don't necessarily have to write it exactly that way. So when I graph these, I should get the same solution. So second calc, 5, enter, enter, enter. And we have 2.9 and 1.3. All right, so now you've seen how to graph by hand and using the calculator. There is a short lesson coming up right after this, which is going to talk about numbers of solutions. And then following that, in the next few days, we're going to get into solving algebraically. All right, guys, thanks a lot. Have a great day, and we'll see you soon.